Okay, yeah, you can hear me. So I have 5 minutes, I think, to present Freemelt on 4 slides. I will be as quick as I can. So Freemelt is a company that started 3 years ago in Gothenburg. Exactly 3 years ago today, actually. My team is having cake at this point back home, so we have a celebration today. We were 6 founders with more than 50 years of joint experience in 3D printing. And so this is our first product. It's a 3D printing metal printer that can print with high power in a vacuum environment. And the technology is electron beam powder bed fusion. So our first product is an open source R&D system for material research. And why the hell do we do a research system as our first product? I mean, it's the market for manufacturing, for instance, is so much bigger. And there's a number of reasons for that. And I think I will be on the floor discussion later, and I think there will be some things mentioned about that. So I'll wait with that until then. But I'll just mention one thing, and that is that if you have a plastic printer, I think most of you have used or at least seen a plastic printer. You put in the material, you make a part, and the part is in that material, basically. So if you print in a metal printer, metal powder, you melt the powder, you make the part, you melt it layer by layer. But the material can look in very many different ways, depending on how you melt. So you get a grain structure. There's a lot of structure inside every metal. You can tune the properties by how you melt. So it's really a very different thing from plastic printing in that way. Up to now, we have sold 5 systems to customers. And we are today 17 employees. The system is really, going back to David's talk, it's a lot of science in here. It's mechanics, it's electronics, it's a lot of data handling, it's a lot of physics in there. And I am a physicist, just like you, so for me, the biggest challenge as a CEO is actually to stay away from the daily development work. Okay, so that's a bit about Freemelt in itself, and I will also talk a little bit about 3D printing or metal 3D printing. So this is an example, and it's a very recent example, really. Last week was the first flight of the Boeing 777X, which is a brand new plane. It also has a completely new engine, and this engine has 304 3D printed parts in it. And this is a complete game changer in aerospace, because this is completely new, sort of. So 150 about of those parts are turbine blades printed from powder. And you can imagine how difficult it must have been to qualify a completely new technology for the first time for ages in aerospace. And this project has been going on for some 15 years or something. So this is a complete game changer in something that has been going on for 30 years, but have now reached this kind of maturity. If we go on to the next, my final slide, it's a completely different example and a completely different end of things. So if you would print door handles, which no one would think about doing today, to print a door handle in a machine today would cost above 500 crowns. It wouldn't be economically feasible. But with a high power system like ours, scaled up to a production system, it would be possible to reach somewhere in the region of 30 crowns. And all of a sudden, this technology could challenge casting, which is a $20 billion industry. And it also provides sustainability and lean manufacturing in a way that it can provide new materials with better properties, arbitrary shapes, new products, but there is also an aspect of changing the whole way of manufacturing with local manufacturing in the places where things are finally used, just shipping the raw material around the world. So powder is shipped and it can be shipped slowly, and you can still have much faster manufacturing than you have today. That's the end of our talk. I'm just going to show the last picture, which is, I'm just going to show it. So I just want to point out that lots of things are made of metal in the world.
We'll soon see Ulric back on stage. Thank you so much.
Okay, thank you.